For those who had studied at maths before, and this is like I think the first topic in Form 4, probably. During my time, this one is like the first topic. During your time, I'm not sure. Okay, so functions. This one is again, I would say, easy chapter. Okay. But we will cover not. I think a bit compared to the maths one. Right. So functions. Right. So this is like the objective. So we should know what is functions and types of functions. We will cover basically 4 different functions. 4 only. Okay. So when we cover the functions, make sure you know what is the name of the functions and how to sketch the functions. That's it. Then we are good. Okay. And then we will see like the application of the functions, like a bit of application, just a bit and easy one. 2. So outline here, there is a relation and functions. Like basically before we learn functions, we need to study relations. Okay. And then we have type of function. This one we will cover 4 different type of functions. And last one is obviously applications, easy one. Okay. And this is definitions. So a relation is a relationship between sets of information. That is relation. Okay. So a relation shows the connection between elements in 2 given sets, whereas a function is well-behaved relations. Do you still remember how many relations we have? Yes, 1-to-1, 4, correct? 4 relations. The first one is 1-to-1. Second one, 1-to-many. Third one, many-to-1. Last one, many-to-many. That is like relations. So we have 4 relations there. And not all 4 relations are a function. Only 2 relations are a function. Okay. And definition for a function is a function from a set A to a set B is a corresponding that assigned to each element of X. Okay. So we have examples here. Like we have a figure here. What do you see here? What do you see there? This is a function, right? And this one we have like a figure here. Like this side we call it input. Okay. And obviously this one is output. And how to decide output? It depends on our function. Let's say if we put x equals to 1, we substitute x equals to 1 into our functions. What is our y? So it depends on our functions. Okay. And this side we call it domain. Have you heard domain before? Okay. So input is domain. So what is output? What we call for output? Codomain, yes, correct. One more, like codomain, yes. This one, yes, codomain. What else? Optic. Opposite. Object. Object and image, correct. Which one is object? Which one is image?
Domain is object and codomain is image.
Okay, correct. So this one is object. So this one is image, correct? One more word, one more keyword for the domain. Same.
Range.
Which one is range?
Image.
Image is range, yes. Alright. Codomain and domain, no, codomain and range here, are they the same? Idea? Yeah, the question is easy. Are they the same? Codomain and range. Yes, come on. Yes, answer. I go back and find out. Codomain and range, are they the same or are they different? If they are the same, okay, fine. If they are different, why is it different? Okay. Alright. And normally, I cannot put that one. If I put that one, then you will know the answer. Okay. So this one we have like 3 different pictures. What do you see here? Let's say first picture here. This one. What do you see? My question is very general. What do you see? Machine. Okay, we have a machines there. This one is a machine, correct? Yes. What else? Input, output. Yes, input, output. So how do you read the first picture with the functions there? Yeah, can, correct? So like if you put something here, and like, let's say, I don't know what is that, like something happen inside the machines there, then we will get something output there. Okay. Down here? What is this one? Function. What is this one? Apple. What is this one? Slice. The cut. Okay, so like something happens here, like probably like the machine cuts the apples there. So the purpose, like what is the functions of the machine? Normally we ask the question, what is the functions of the machine? Right, so the function is, what is the functions of you get an iPhone, for instance? You must have like why you want to get that iPhone. Okay, this one, we have a brain, working memory, self-talk, emotional regulations, organizing. How do we really, let's say we ignore this one. This is your brain. Okay. Let's say we are in a class now. So where is the input, guys? So we are in lecture now, we are in class now. Where is the input? Where is the input? Yes, where is the input? The slides. Right, I'm giving lecture is the input. And you take something, and what is your output? Yes, what we get. Your test marks later, your tutorial, your assignments. Okay. But the problem is like we are in the same class. You have the same slides. You have the same like me teaching you. Right? So basically the input is the same. Correct? Right? And then what functions do we have? Like we have assignments, we have tests, we have final exams, and the output is different. Why? Because you get different input. Yes. Okay, that is the function, guys. So make sure like when you come to the class, at least you get something. At least you get something or you learn something. Alright? Alright? So in general, a function if defined, f is defined for a certain values of x only, the sets of values of x for which f is defined is called domain of the function. The set values of y or fx for a given domain is called the range of the functions. So basically like if you put something, we call it that one is domain, and the output we call it range. Okay, not codomain, but codomain is on the right too. So go back and find what is the difference between codomain and range. There is a slightly different, slightly only. Then we have this example. This one is very mathematics one. Given that A is like element from 1 to 5, 6, and 8, B is 2 and 3, and R is a relation from A to B defined by R equals to AB. So A is elements of A is elements of capital A, and A is divisible by B. So try this one, guys. Find R, B domain of R, C range of R. Try this one. Because I want to explain something here. The question is easy. The problem with the function here is like we need calculations here. Like we need either like addition, subtractions, or a formula. Then we can do. This one like we don't have any formula. And how to solve this one? Try. what is our functions in this example? Which one is our function? Which one is our function? R is our function. So R is defined as elements of A, B. So what is A? So A is elements of A, and A is divisible by B. So where is the problem? I see some answer already. So this one is like put my papers before they give an answer. What is the problem, guys? What's the answer? What's the answer? No answer. What's the answer? Okay, what's the answer? Okay, guys. Ideas. I think somebody got it correct. Okay. So first one, we have A, we have B here. So what is the problem? When you read the questions, which part of the question you should, what? Which part of the question you don't know what does it mean? Or the whole question? What is this one? A. Okay, correct. This one? B. And what is R? Relation, like connections between A and B. Okay. And defined by this one. So what is small a here? Small a refer to the elements in A. This one we have capital A, correct? So A here it can be 1, it can be 2, it can be 5, it can be 6, it can be 8. And B here? It can be 2 or 3. Understood? Small a and small b then? Alright. And R here, no. A here, so A is element A. So what does it mean here? Then what is the elements of A? So A we have 1, 2, 5, 8. And B 2 and 3. Alright? And R we have like, generally R they write like A, B. Then they have conditions on A and B. Correct? So how to start this one? Basically, you pair all the numbers. How to start? Ignore the R first. Pair all the numbers. What does it mean? Because this one it says like AB, right? So I mean you list all the possible answer. So probably we have like probably we have like 1, 2. We have 1, 3, correct? Then we have 2, 2. We have 2, 3. What else we have? So many. 5, 2, 5, 3, 6, 2, 6, 3, 8, 2, 8, 3. Agree? So these are the possible pairs. Because we have like A, B there. Agree? Alright. So now you list all the possible pairs. Now we have like how many? 1, 2, 3, 4, 5, 6. We have 10s there. Right? So now you go back to R. What is the condition for A? A is elements of A. So basically like the whole thing here, like this one, this one, this one, until this one are from A, right? What is the condition for B? And it says here, A is divisible by B. What does it mean? Divide. Okay, can divide. What is divisible? Okay, correct. Divisible is boleh dibahagi. What does it mean? Let's say we take like 2 divided by 3. That one is divisible or not? Yes, no. Why no? Sebab? Yes, your answer is correct. No. Why? Divisible is boleh bahagi, betul. Correct too. Well, what is divisible? What is like the precise definitions of divisible? Okay, correct, round number. What else? Correct, round number is correct. Don't have point, correct. What else? No, the answer is correct. What else? The strong keywords there. Round number correct. Point, correct. Don't laugh, that is correct. Divisible. Like 6 divided by 3, that one is divisible or not? Yes. Why? Because round number. Because no dot. What else? Even number, not really correct. Because if you take 12 divided by 4, we have 3, correct? 3 is not even number. What else? Sify. What is divisible? No fractions. Okay, no fraction is, I think it can relate to whole round number. Whole number or round number? Round number. What is divisible? The punch one. Somebody say something.
Without any reminder.
Yes, thank you so much. Without reminder. Probably he Google somewhere. It's okay. Yes, divisible is like the remainder is 0. That is divisible. That is like the punch one. Okay. When your friends say round, correct. Like 6 divided by 2, we have 3. 3 is round number. Okay. And your friend say just now no point. 3 is like 3.00 is also point. Okay, but there is no remainder. That is divisible. Clear? Alright. So now you have to check. It say A is divisible by B. Basically like A divided by B, remainder is 0. Or like A divided by B, you get like a whole number, a number. Okay? So out of these 10 possible pairs, we check one by one. So this one, if 1 divided by 2, we need to take or not? Why? Because like there is a remainder or no round number. Okay. 1, 3? No. 2, 2? Yes. 2, 3? 5, 2? 5, 3? 6, 2? 6, 3? Yes, no? Now we have two different answers from the same question. Like we have the same input but we have different output now. 6, 3? Yes or no? Yes. 8, 2? Yes. 8, 3? No. Okay, so what is your answer for R now? So therefore R is 2, 2, 6, 2, 6, 3, and 8, 2. Clear how to decide R? Yes. Why? Okay, clear? Good. So this one is question A, I believe. So what is question B? They ask you domain. What is your domains now? So from question A, we know that domain is always on the left, correct? And range is always on the right. So based on your answer here, pick the number on the left. So what are your numbers? 2, 6, 8. Don't write the number twice. Like, even though we have like 6 twice, right? Just write one. Clear domain? And last one they ask you? They ask codomain. They ask range. So range, from the diagram we see like range is on the right, correct? So this number, which one is on the right? 2 and? Don't forget the curly bracket there, guys. Clear? Clear? You got it? Okay. Alright, I hope we have the correct answer. Yes. Answer is there. Okay. But if I show you the final answer, then like you may ask how do we get the final answer then. Okay. Alright, so next one is functions notations. So my question is, you know what is functions? What is notation, guys? What is notation? Come on, what is notation? Symbol that represent function. Okay. So notation is like symbol or the way we write a function. What does it mean here is like, let's say you have Facebook, right? Okay. Do you have Instagram? How do you write Facebook? Do you spell in full? How do you write? FB something. Probably. Then you know, okay, FB is Facebook. Like your Instagram, you will write IG. That is notation because we don't want to write in full. Okay, and what else? Like that is notation, like the way we communicate. Okay, so for functions too, we don't want to like every time every time we have a function, we don't want to like sketch this diagram. Okay, we want to write like a very simplified versions one. So we need a notation. And this is the notation we use for function. If you see this one. So f double dot x to y. Okay, or sometimes generally when people are so lazy, they will write this way: fx equals to 1. So these are functions, and there are different notations too. Clear? All right. So this one is easy to write, but what does it mean here? So obviously, f here is, what is f there? What do you think f here? Functions. Oops. So f here is function. Oops. So f here is functions. Sometimes you will see like gx, hx, mx, all the small letters one. That one is a function. Okay. And what is x here? Object, correct? We don't use object anymore. Domain. Okay, so x is your domain. Okay, so we know f is functions, x is domain. Where is your range? The arrow y, yes. So y is range. What else is range? Y is range, correct? X is domain, f is a functions. Fx, if you find fx, f only is function, x only is domain, y only is range. But fx together, they are range. Okay, and you see from the notations here, we can identify functions, domain, and range type. Question? Okay, Mel? Alright. This one, we have two examples here. Or probably you have this one. Let's say in high school, probably you see like y equals to 2x plus 1 and fx equals to 2x plus 1. They are the same, right? Y equals to 2x plus 1 and fx equals to 2x plus 1. Okay. So normally, for a function, we don't write this way. Normally we write this way for a function. So if you have the function something, then you can use hx, yx, fx, etc. Okay. And normally this one, how do we call this one? Normally we call this one we call it linear equations. Down here we call it linear functions, but they are the same, almost the same, but the way we write is different. Okay, and if you compare above here, what do you notice the difference there? Fx and y. Okay, so if your question asks you to write a functions, my suggestion is use this one: fx, hx, gx, etc. Okay. Where is the question? Given, fine. Exercise, operational functions. Where is this one? Okay, I need to. This is like. Let me see, what do we miss there? Okay, why we missed there? Okay, we have examples here. This one is easy. I hope you can do this one. So example, given fx equals to this one, right? Yes, okay. This one is OneDrive. Let me see how to I counting here. Open in another apps. Okay, try this example, guys. Given fx equals to minus x squared plus 6x minus 11, find f negative 10, ft, and last one is fx minus 3. Do it now. I said same input, different output. What's your answer for question A? This one, guys? A? Negative 51. Same input, different answer. He has different answer. So which one is the correct one? Okay. Come on guys, sepatutnya dari 5 minit dah siap. Finish your tutorial topic 2? Started? Alright. Dia panas, dia panas. Kamu dapat apa jawapan lain? Jawapan negative x squared. Kamu dapat apa? Jawapan soalan C. Salah. Either one is correct. Kamu dapat apa? Minus 2 plus tu. Dia dapat minus 38. Tu kawan kamu tu?
Minus 38.
Minus 38. Dapat C. C. Lain pula. Sama. Tapi dia have difference. Dia have sama tak? Dia dapat plus plus 6 kan? Plus 12x lah. Dia dapat plus 12x. Boleh pasti kan? Okay guys. So first one guys. F negative 10, what is your answer? Negative 171. Okay, if you get negative 171, yes, you are on the right track. B? Just sub X with the T. C? Negative X squared plus 12X minus 38.
Yes.
Can you write down how do you change to the different sign kan? Tadi kamu buat different sign kan yang kau padam tu. Tengok ke depan tu. I want to explain something. Write your final answer. Fx equals to fx negative 3 tu. Okay. Okay guys, thank you. Listen carefully guys. This one okay, this one guys. This one the final answer, right? Fx equals to minus x squared plus 12x minus 38. And here, if you see like from this step to this step, we have like x squared minus 12x plus 38. So basically like we only change the sign. Like from negative, positive, positive, negative, negative, positive. Question is, can we do that? Yes or no? Yes or no? Yes? We cannot get. This one is wrong. Why? I think yes. Probably because you use, let's say we have like negative x squared plus 12x minus 38 equals to 0, right? This one, then because of equals to 0, then we can change. If equals to 0, yes, fine. But this one, fx, we don't know our fx. Okay, so if you have fx here, if you change the sign, so basically it means like this one you write negative fx. So only change the sign when we have 0, but we don't have, if we don't have 0, don't change the sign. Stick with the sign. Okay? Alright, next one. Why I don't have this one? Pen setting. This one is. Okay guys. This one we have operations on functions. And you know what is functions. So what is operation guys? Yes. In mathematics, when we see operations, what does it mean? We are discussing about plus, minus, multiply, divide, or division. So next time when you see operations, you think, okay, addition, subtractions, multiplications, and division. Okay. So here when this one is exercise, guys. Go back and do this on yourself. Just now. Can you snap? Portrait landscape. Okay, so this slide, what does it mean here? Operation on function, what does it mean? If you have two different functions, or if you have one functions, we can do addition, we can do subtractions, we can do multiplication, and we can do divisions. That is what does it mean from the slide. Okay, so here, so this one is addition. So if f tambah g, so basically just f plus g. Okay, second one is minus. So if you have like subtractions there, so we take function fx minus functions gx. Okay, careful when we have negative there. Okay, and third one is the product of two functions. The product here, what does it mean? Multiplications. Okay, if you have two functions, then we can multiply the functions. And this one we have quotient. What is quotient? Division. Okay, if you have two functions, fx and gx, so we can divide by the functions. But here, like let's say if we take fx, divide by gx, and we have conditions, and gx cannot equals to 0. Do you know why?
Because we can divide by 0.
Yes, because we cannot divide by 0. So if you have fractions there, normally the denominator we cannot have equals to 0. Okay? Clear? What is operation? Okay, now try this example. Probably. Let me check. What is your answer? Dewi. What is your answer? Say? Sama tak?
X kuasa 2 atau tak tutup X.
Tolak?
Tolak 2.
Okay. Yes, different answer. Come on.
Ada lagi.
Guys, put down your pen first and pencil. This is like the independent and dependent one, you know? Yes. Like you are dependent on your friends. That is dependent. Okay. Second one, guys, listen carefully. People out there, like they are like they respect you guys very much compared to the matric students. When I told my friends there in matrix, like I'm teaching foundations now, and then they say, senanglah kerja you. Dia orang pandai. Yes. That is the assumptions there. And my students there, untung saya dapat budak-budak yang pandai. Lepas tu saya kata, I cannot comment on that. I don't want to comment. So people out there, they think like when you are offered to be in any asasi program, either from which uni, okay, they expect something from you guys. Okay. So that is the reality out there. Okay. But the reality in here, okay. Okay, now continue. Dapat dah? Okay. Dapat? Dapat? Do I have marker? Okay guys, listen, I have marker now. I hope. So we have there is fx equals to 4x minus 3. And our gx is 5 x minus 1 and x does not equals to 1. Do you know how do you get 1 then?
X minus 1 equals to 0.
Yes, just take x minus 1 does not equals to 0 and x does not equals to 1. Okay? So the first one here, we have like f minus g there. So basically we have to do subtractions. Okay? So f minus g. So this one, what does it mean here? Just take fx minus 3 minus 5 x minus 1. Then. Correct? Then. So the problem here, guys, listen. The problem here not because you don't know the multiplications or subtractions and those operations. That is not the problem. The problem here is how to simplify this one. Okay, and this one like you studied this one since, I don't want to say standard 1, probably like form 1 until form 5, alright? Probably, I don't know. Okay, the problem is to simplify this one, okay? And you have to be careful with the negative one here, negative here, and the fractions. Okay? So in math questions, if you want to trick you guys, normally we will do like negative something. Because we tend to make mistake when we have negative. That is the first one. And second one is, if you want to trick you, then we will give you fractions. Because like some students, they cannot simplify fractions. Okay? So here, how to simplify this one? This one because you cannot use calculator. Normally fractions you will press calculator. Even 1 plus 1 you will press calculator. So this one? Yes, because if you have like one is not without fractions, the other one is with fractions. We have to like make the term without the fraction one is a fraction. Okay, so this one, we multiply this one with, multiply with x minus 1. Okay, so what do we have here? 4x minus 3, so x minus 1 divided by x minus 1 minus 5 x minus 1. Agree? Next step. What do we do here?
Expand.
Expand. So expand here. So we have something down here, we have x minus 1. So up here, this thing is. So the first one is? Second one? Third one? Next one? The next step? 4x squared minus 7x minus 2 divided by okay. What I will do here on my tablet here. Why it's blank? What happened? I will check my slide again because I convert to PDF. I don't convert to PDF. This one convert to PDF. This is the answer for B, guys. 4x squared minus 7x plus 3 over 5. Correct? No, you will get these slides later, but I won't share now because the solution is there. If I share now, then yes, you just relax there reading the solution. Alright, take this one exercise. Oh, take this one exercise. This one is for additions and multiplication. Don't do it now. Just snap, they do it later. Alright, we'll cover first one, types of functions. Okay. How many functions we will cover? 4. Linear, quadratic, exponential, and logarithmic. And today I believe linear functions only. Okay. Dancing mathematician, guys. I won't dance, okay. Don't ask me to dance. Like this one, they put like general idea how to sketch a functions lah. So up here we have like this one is y equals to 1. You can do this one if you are sleepy or somewhere, and you can go back the whole thing. Dancing mathematics. This one is like general idea of a shape for a function. Okay. Alright. Here, linear functions. So first one is functions. You know what is functions now? Yes. What is linear? What? Line. What else? Straight line. Okay, what else? So our answer now is we have like first one we have line. Second we have like straight line. What else do you have? Come on, there is no right or there is like I need to know like your background first. Like what do you have in mind when I say linear functions? What? Consistent. Yeah, what is consistent there? Remainder. Yes, gradient consistent. Yes. What is gradient, guys? Kecurunan. Slope. What else? What is linear? Power is 1. What power? Correct? Yes. X power 1, correct? So x power 1. What else? Anything you imagine when I say linear, anything that you imagine. Thank you so much. Y equals to mx plus c. What else? Y-intercept. Yes. I don't know where to write. That's why I need my note. Because this one is like PowerPoint. Y-intercept. X-intercept. Yes, math is easy. Don't make it tough. Okay. What else? Any equations you remember related to linear? Y equals to mx plus c, yes. And how to find gradient if you remember? So m is y2 minus y1 divided by? Correct. What else? You might need the whole thing. Ada lagi tak? If y equals to mx plus c, so y is y, m is gradient, so x is x. What is c there? Y-intercept, correct. What else do we have? Come on. We need graph, straight line graph. Okay. Straight line is a graph, okay. X. Y exists, X exists, yes. Sometimes, have you seen this form? So, what is this form? X over A plus Y over B equals to 1. Oh, you haven't seen this one. Ni apa? Bab 7 pula dah. Yes? What is A there? What is B there? Just now I asked you C, you said Y-intercept, correct? Now we have like X over A plus Y over B equals to 1. What is A there? Betul tudung pun boleh. Okay. What is A there? That one is, okay, the whole thing here is intercept form. Okay. So what is A there? Yes, A is X-intercept, B? Y-intercept. Okay. Alright, at least we have some idea. So this one, we have a diagram here. Do you agree that one is linear function? Yes? Why? Because we have like a straight lines there. Okay, when we have a straight line, yes, we need a ruler to draw a straight line. Even though you are very smart or you are an artist, use a ruler, guys. Okay? And what is the general form for linear functions? Up here. Fx equals to ax plus b. If you are given if fx equals to ax plus b, so what is a then? Kecurunan. So A is your gradient or slope. What is your B then? Y-intercept. Okay. Alright, so this is like different forms. You might find this one useful. So first one, we have general linear forms, which is AX plus BX. I don't think AX plus BX plus C. I don't think that one should be AX. Remove the x there. AX plus BX plus B plus C equals to 0. We cannot have x twice. Okay. Second one, slope intercept form. What is this one? Oh, that one is BY. Can you see there? Like here we have like 2x plus 5y plus 1 equals to 0, right? So this one should be y. No? Okay, and second one, slope intercept forms. We have y equals to minus 2 over 5x minus 1 over 5. So this one is like y equals to mx plus c there. Okay. Third one is intercept form. So we have like x over negative 1 over 2 plus y over negative 1 over 5 equals to 1. And point slope form, we have like 1 minus y1 equals to n multiplied by x minus x1. Do you know how do we get this formula? We modified from here. We modified from this one. We rearrange this one. N equals to y2 minus y1 over x2 minus x1. We will get this one. Okay? And vertical line is x equals to 10. Which one is vertical line? Vertical one. And horizontal line? Okay, so x10 is vertical, y12 is horizontal. Sketch the graph of 2x minus 3y plus 6 equals to 0. Sketch. Try. Yes, try to sketch this one. Normally I don't sketch. Normally I use like calculator one. So sketch this. Yes, I need a straight line. You can just do the one. Di ini ni, guys, di ini ni kamu boleh tanya adik-adik kamu belajar form 1 kot. Malu je kamu ni. y-intercept there? What is y-intercept? What is x-intercept? -3. Okay. This line going up or going down? Increasing or decreasing? Increasing. Macam tu lah. Yes. If you know like y-intercept is 2, correct? X-intercept is -3. So use these two intercept to draw a straight line. Then you get your graph. -3 now. What is your y-intercept?
Oh, 6.
Guys, what is y-intercept? So y-intercept to x-intercept -3. So when we did this, when we have this information, Dah. This one I don't use the notebook, guys. This one is like Microsoft. Here is solution. Okay. So we have 2 there. Oops, sorry guys. We have 2 there. That is our y-intercept. This one is our x-intercept. So when we have y-intercept and x-intercept, we label the y-intercept somewhere here. And we label the x-intercept somewhere there. So next step, take a ruler, draw a line that passes through these 2 points. Okay? And then label this one as x. This one don't use y anymore. This one we use fx. Okay? And label this one as fx equals to this one is not fx. This one they give you what is the equation? 2x minus 3y. 2x 2x minus plus or minus minus 3y plus 6 equals to 0. Label. Clear? Question, somebody?
Yeah, I go in. Just my brain hanging.
Okay. Somebody like got the wrong y-intercept. Yes. And listen guys, and somebody miss like y-intercept becomes x-intercept, x-intercept become y-intercept. Yes, somebody put like 2 here, minus 3 there. Correct. Like 2 and 3 there correct already. But the axis is wrong. Okay. Just now I want to say something, I forgot already. Oh yeah. For linear functions, guys, we have two shapes of the linear. So this one is increasing. Do you see the increasings there? Listen guys, I want to conclude this one. So if increasing, what happened to your m? So if your m is positive, or if your gradient is positive, and then this one should be increasing. Okay, and the other one, your graph may look like this one. This one is decreasing. So what happened to our m? Negative. So the shapes of your linear, either increasing or decreasing, depend on the value of m. Okay? Alright, then linear equations, quadratics on Wednesday.